There you are, Brujo.
All
I
right.
guess you can start.
So, uh, welcome to this edition of the Elixir remote meetup. Thank you very much for joining. Thank you, Vinicius, for organizing. And this talk is about my personal story. Um, I'm an Erlang developer, you can say, but lately I've been involved much more with Elixir. And while I created this talk for Erlang folks, specifically thinking in what I've learned in my life as an Erlang developer, I think many of these lessons apply to the Elixir community as well. So let's see how it goes. So basically, this is me. I am Brujo. I live in Buenos Aires, Argentina. But since I work remotely for Adroll, I've been working in the last 2 years from many places in the world. You can see me there working from Venice, Italy. But I actually carried my computer there. And I did some work over there while I was there. In my spare time, I write a blog which is called Erlang Battleground. And lately, we because I'm incorporating writers to it, I am working a little bit more as an editor now. We have been writing some Elixir stuff, and my latest blog posts are basically written for Elixir folks. I also organize Spawnfest. You can see the pretty head with the light bulb there, which is a contest for the Erlang ecosystem, for people to join some teams and work for 48 hours on a project. Registration is free, and you can win some awesome prizes that are provided by our sponsors. The next edition will be September 21st and 22nd. I also organize a community of open source developers called Inaka. You can see the little armless dude on the bottom side of that slide. That's our logo. It's called the Inako. We are a group of developers from different languages, different backgrounds, etc. But we all work in maintaining our about 75 open source repositories, and we organize events, and we find stuff to do for all of us because we love these kinds of things. And that community is also open. If you want to join, just check the guidelines on GitHub. The GitHub handle is Inaka, and you can find the guidelines there. Okay, but enough about me. Let me go back in time and tell you the story of when I started working in Erlang. It was more than 10 years ago, and we didn't have, for those who know Erlang stuff, we didn't have rebar, we didn't have a makefile, we didn't have maps, we had records, which was not so good. We didn't have a logger, but no, I'm not talking about the actual logger that now comes with OTP. We didn't have even logger. We didn't have anything. One of my first projects was a logger for Erlang, and it was terribly bad. Of course, there was no Elixir, no LFE, no FN, no any other language other than Erlang. No central repository for stuff. If you wanted to manage dependencies, remember, you didn't have rebar. You could use Git submodules or some other external stuff. Maybe write some makefile thing to download the dependencies for you. There was no linter whatsoever, no formatter, no nothing like that. And what was the most troublesome thing for me, because I came from Haskell, which was a statically typed language, was that there was no type checking, which was fun. I also enjoyed Smalltalk quite a bit, but I knew that there was the Elixir there that could do some type checking for you, and I was fascinated by it. But then I discovered that running the Elixir in the smallest project possible took about an hour, and it was like, whoa, man. And yeah, even with all those issues, Oh yeah, and there was, if you're willing to investigate some crazy stuff, just check what parameterized modules were. It's look at Mocky Web if you want. It's a very strange technique that we used back in those days, and luckily we don't use them anymore. But again, despite all those things, I loved the language, and I started working on it like full on, like for every project that I developed back then, and that's and since then until now, that's all I've been doing. And during that time, during those 10 years, many things have changed. Many things have become better. And so, following the tradition of my people, let me invite you all to gather around the campfire and share some mates with me. Cheers.
Cheers.
And let me tell you the story about all the things that I've learned during these years. The first one, comes from my experience as an Erlang trainer. So there are many things in which these languages are different from the mainstream ones, right? Particularly, they are functional, they are concurrent, they are designed with distribution in mind, with fault tolerance in mind. All those things can be are native to the very bare bones of the languages, and so they have to be told. So when I teach Erlang or when I teach Elixir now, I start with, well, this is a function, this is how you do recursion, this is how you create the process, etc. Sending messages and all that stuff. But usually my final lesson is, don't do that. Don't write those things. And you will think, why? If that's the key part of the language. Well, because abstraction. Because when it is super convenient, it's necessary, I would say, for people to learn how to do recursion, how to spawn process, how to receive and send messages, how to handle exit signals, etc., etc. After a while, you realize that somebody before you already had to deal with all those things, and they abstracted those in much more convenient things. For instance, higher order functions instead of recursion. That way, you can use functions in the enum module or list module or maps or whatever, and you don't have to worry about properly configuring, properly choosing your base cases, properly applying recursion, optimizing for tail recursion and whatnot. It's all given to you in functions that already come with OTP. And the same goes for processes and messages and exit signals. You have OTP behavior, OTP supervisors, and all the other things that are around it that lets you write only the specifics for your code, and don't worry about how to properly spawn a process and how to monitor it and how to send the proper message and do the things that you need to do for it to be properly synchronous, etc., etc. But it doesn't stop there. Once, while working at Inaka, we saw that for many applications we needed multiple workers in a pool, and their function will be the same for each one, but we had to distribute the work among them. And we abstracted this pattern into a library called worker pool. And then we figured out that many other people did the same, and they created, say, Pool Boy and 10 others. There is a talk by, I don't remember who, but it's called How to Choose a Pool in the Erlang World and not drown in it. And it's basically that. Everybody invented worker pools. And each one of those implementations has its own particular flavor. But in general, the idea is the same, to abstract the concept of multiple workers doing the same or similar tasks and put it in a library so people can just start a worker pool or a pool in Poolboy or whatever and use it. They don't have to worry about how to spread the load, what to do when a worker is stuck or heavy loaded or whatever. And the same thing for many other things, like database connections. We have Presto. We don't have to think about all the internal stuff that Presto needs to do. We just write the queries and we are done with it. Again, it's important to know how these things are built to understand what happens and to be able to debug it. But in general, it's much better to use the higher levels of abstraction and just worry about the specifics of your system and not the things that are general to any other system. So my tip is use higher order constructs instead of building everything from scratch. And for the next one, this is one that is particularly important for Erlang folks. For Elixir, we are lucky to have def struct, but in Erlang world, we don't have def struct. So every time we have to model a different type of entity, we have to decide how to do it, and there is no particularly better way. And so sometimes we use records, sometimes we use just tuples, maps, something like that. But the general rule that I like to transmit is that those types should be properly specified, and if possible, they should use opaque types. If you don't know what the opaque types are, I wrote an article about them not too long ago. It's called Help the Elixir Help You. And basically, the idea here is that it's something that object-oriented folks knew for a long time, which is keep the internal representations of your objects, or structs in this case, contained in a single place, in a module or something like that. That way, if you ever need to change the representation of, in this case, the examples, you can change it, and you only need to modify your module. It goes a little bit against pattern matching and all that, but in my experience, the benefits heavily outweigh the downside. So my tip is to encapsulate the representation of the data using opaque structures. And you will see in a couple of tips ahead, use the Elixir to verify that encapsulation actually happens. My next tip comes from my experience as a Smalltalk developer. If you ever worked in Smalltalk, you should have seen that it is so easy to work with test-driven development that if you don't do it, you are like working harder. So when I came to Erlang, I tried to do the same, to work with test-driven development in the same way as Smalltalk. But at that time, I thought that will not be that simple, right? But actually it is, because even when you have fancy test frameworks like XUnit or Common Test for Erlang, you can, even without those things, you can still do test-driven development, and you can base that in the fact that the language is dynamically typed, like this. You see, this is how I generally start all the exercises in my trainings. I write a test function with 0 arguments, and I use pattern matching as an assert mechanism. Each one of those lines is actually an assert. It's like the equivalent of the assert in XUnit or whatever. And basically says that whatever is on the right side of the equal is equal to what's on the left side. And so if that is not true, the test will fail, which is exactly what we want. But there is another key part in this. That module compiles. And that's because Elixir is dynamically typed, and so it doesn't need to know run length before it is going to use it. I could not have written that test with a private function, though. That's true. I need run length to be exported public, and that's because with private functions, the compiler will check that the function actually exists. But with these kind of things, if I use fully qualified names, I can run the test with no extra code, just the test as test-driven development wants. And then I run it on the console, and I get something like this. It tells me that I need to create the function run length 1. And if I create it and I put the wrong parameter, or I do something wrong, the test will tell me what's wrong, and I will be able to work on it. Of course, working on it working with XUnit or in Erlang with common test, it's more complete, or it gives you a whole thing with HTML and documentation and coverage and whatnot. But with these kinds of things, are enough for you to do test-driven development, even for the smallest projects. So I believe there is no reason not to do it, and the benefits of doing these kinds of things are well known. And so I think my tip is just do it. Write your tests, even so as simple as the one that I showed you before, and develop your systems incrementally using test-driven development. And on that same line of thought, I borrowed a term from one of my mentors several years ago, which is called meta testing. It comes from people that like statically typed languages asking, hey, you have a dynamically typed language. You don't have a type checker on compile time. How do you detect those bugs? And the answer is generally tests. You just add enough tests to detect those things. If the test pass correctly, you can assume safely that you are calling the right functions with the right arguments, etc. It's kind of a weak argument, I would say. But on the other hand, you have more tools for Elixir that will help you detect those type checking bugs, or the same kinds of bugs that the type check system will find. You just need to use them, and you can add them to your tests. In Erlang, you can use sumo test, I think it is, or no, katana test, which runs those things on inside your common test suite. But if you don't want to use that library, you can, as long as you can add several targets to your mix. And for instance, in almost all of the systems we develop in Elixir, we have an alias called, I think it's mix CI or something, that basically runs the tests, then runs format, credo, xref, and dialyzer. So we can make sure that from the very first day of the existence of the project, no code got merged in without being analyzed by dialyzer, xref, credo, and formatted properly. And that ensures code quality. And also, since we're running dialyzer from the very first day, each time we have a dialyzer warning, we know where that warning comes from. It can only be from the code that got inserted in this change. And so it raises up the quality of your code. Particularly for open source libraries, it's really important. And these tools, the great thing, except Credo, is that they come with the language itself. So there is barely any reason not to use them. The formatter, we can discuss. I have some ideas about it, but the rest of the tools, they are super useful. And again, those are not the only tools you have. Do you know that you can configure your shell, your Elixir shell, with a simple file called .iex.xs. In that file, you can put whatever command you want, even assigning values to variables, and then you can have it you can see it on every shell. I use that to create functions like some helpers for Git, so that I don't need to go outside of my shell to run Git stuff. I have it there. To load some modules like Redback that I want everywhere, or recon or stuff like that. It's very, very useful. And another tool, different thing, you can use in every Elixir node, you can use stuff like this, the observer, that will show you a snapshot of your system, but it's also live. It's not, and it's also interactive, which is even better. You can see your processes, you can see your tables in ETS, you can kill processes, you can see your supervisor trees, the load of your system, and many, many, many other things. I use this in my development environment a lot, but in production, I don't trust it so much. And so I use the things that are below this visual surface, which are stuff like Erlang system monitors that will warn me if there is a large heap in any process, or other things. It will emit warnings if there are some things that go beyond the levels that you specify, or maybe Erlang system info that has a lot of information. Remember, when Erlang was created, one of the most important needs that it solved was the ability to maintain large systems, and monitoring, tracing, analyzing the system, getting stats from it was very, very important. And so Erlang is full of these kinds of tools that help you do that kind of thing, and many other things. I understand that the Erlang documentation may not be the most helpful one, the most properly written, or the most understandable one, but I encourage you to take your time and go through what is included in OTP. There are many cool things there, and you will learn quite a bit. And there are many things that you can eventually use that if you try to find them when you actually need them, that may be too late. But if you know about them beforehand, they became pretty helpful. So that learn about the tools that comes with Erlang OTP. You will see that there are many things that you think you have to create for your system in particular that it's not true. They are already there. Another thing that took me a while to understand was that in these kinds of languages, you usually don't debug, you trace. Because debugging will help you with sequential code. And there are very cool tools for that, like the debugger or IXPry or break. And if you want to debug sequential code, you are good with that. But in general, the most complex errors happen in concurrent code or in high load code, where the debugger or pry or whatever are not the best tool for the job. But the people developing Erlang OTP knew that, and they knew that for quite a long time. And so they created DBG and their associated tools. DBG is a very not user-friendly tool, but it's extremely powerful. You can debug almost anything. You can trace whatever you want in different processes, in new processes, in old processes for a period of time. There are lots of things that you can do with DBG. But as I said, it's not the most user-friendly tool. So some other people created wrappers around it, like Recon or Redbug or Rexbug for Elixir. I recommend you to include those things in your releases, because the day you need to debug stuff in production, you will use them a lot, and they are super, super helpful. And in particular, those two, Rexbug and Recon, they are production ready. They won't crash your machine while they are trying to help you understand what's going on, which is something that by yourself you can do. You can end up doing if you don't know exactly what to trace or how. So these tools are great for concurrent code and for running on production environment. You should take a look at them. You should practice on your development machine, so when the system is in production and you want to debug it, you can. And of course, there is another tool. I bet you didn't know this one, but this one actually exists. It's the Erlang tracer, and it comes from another planet. It's impressive, and it's so simple that there are only 2 commands. You can do et viewer start, and then you can add as many et phone home calls you want, and that will result in some nice interactive sequence diagram that is not static. Like it evolves over time as your processes send messages to each other in the system. So this again is another reason to go through the OTP libraries, because maybe you want to do this at some point and you didn't know that there is already a tool that allows you to do it. So again, get familiar with your tracing tools. And finally, the last 2 tips are more general, not particular for the code and the application on the language. So the first one, in this for Erlang folks is super important. For Elixir folks, I believe you are more used to it, but basically these languages are very particular, and sometimes they are really hard to learn and to get familiar with, and it's much more easy if you do it with others. So I encourage you to look for meetups in your area. There are meetups everywhere. Yesterday I was trying to promote SpawnFest, and so contacting different meetup organizers, and I know for a fact there are meetups in Sydney, Australia, in Tokyo, in Japan, in Braga, Paris, many cities in the US, Buenos Aires, and some cities in Brazil, Mexico, different places in Mexico. And if there is no meetup in your area, just create one. Getting together with people with the same that are learning the same things as you do is super, super useful. And if not, conferences. Conferences are a great place to find other people facing the same issues or creating tools that might end up helping you. SpawnFest, of course, because I organize it. I have to promote it, but it's also I organize it because I once was a participant and I enjoyed it a lot. So when the contest was over, Amilcar and myself, a friend of mine that works in Dubai, and myself, we decided to start organizing it again because we really, really think that it's a great chance to learn, to share your code, to help the community, and to get in touch with others that are on the same path as you. Again, the Slack, the forums, and now we have the Erlang Ecosystem Foundation. I am part of the work group for education, and I think it's a great initiative that will help start or kickstart processes or ideas or contributions that will be very beneficial to the community and would otherwise not start because they don't have resources or they don't have a framework to do it. I think joining the Erlang Ecosystem Foundation, even in the free tier, it's a great thing to do. If you don't join it, at least subscribe to the newsletter. There are many important stuff being published there every week, and you will find it very useful, I think. Once you are on the other side, once you have enough knowledge to share, I encourage you to write blogs. I think I've said this many times. The first article you write is always the hardest, but particularly in this community, the welcoming is amazing. It's amazing. I've seen blog posts written in other communities like the JavaScript one, full of hateful comments and like trolling and whatnot. This community is nothing like that. I received a lot of love for articles that are super dumb that I've written, and I think it's a good thing to share knowledge, and it will also help you grow in your own understanding of what you're trying to share. asking questions and showing what you do in conferences, and in particular in open source projects, is always super helpful too. You don't need to create new open source projects. They are open source for a reason. You can contribute to existing ones. So in general, if you're interested in these languages, if you're learning this, just ask for help. It's a very, very welcoming community. And finally, my last tip is actually not mine. It comes from Joe, of course. Who else? And I actually have this printed out, or drawn, I will say, written by an amazing guy called Rob Carbone. I have it here behind me on my wall, and it basically says, make it work, then make it beautiful, and then if you really, really have to, make it fast. So I think there are two ways of seeing this. Of course, the obvious one is that, yeah, you don't go for the optimization as your first thing. First, get your code to work, and then make it beautiful. But there is also another lesson in this. You can make your code beautiful. These languages allows you to do that. And if you can write beautiful code, then you can enjoy writing beautiful code. And I think that's extremely valuable, and that's something that not every language can provide. So my last tip is that you can enjoy working with these languages and write the best code you can, because they allow you to do so. Thank you very much. And of course, get ready for SpawnFest. We are 1 month away from it. And that's it for me. Questions, stuff like that, conversations.
Okay. Well done, Brujo. Amazing talk. And let me ask you the first question. You have a lot of experience, more than 10 years with Erlang, and also now heavily involved with Elixir. And looking back on your career since the beginning, you mentioned that usually beginners, you encourage them to use high-level constructs, and also the other tips that you gave. But is there any particular construct in Elixir or Erlang that you wish you learned sooner?
Yeah. I wish, actually not learn, I wish I had those things sooner. Opaque data types, for sure. Because before them, I tell you what was the terrible thing about not having those things in Erlang. You need some structure, say, whatever, a player. You're building a game, and you have to collect some data about each player. And you represent that with a record. In Erlang, representing stuff with a record requires you to share the record definition among multiple files, modules, if you want to pattern match on it. And if you're representing it with a record, you generally want to. So if you do that, then you have to put that record in a header file or something like that. And each time you change something, you have to recompile all those records, which is fine as long as you are in one application. But if you're working on an open source library, or if you're working on a library at all, like open source or not, and then you have another one using it, if you change something in the record in the first one, you have to go to your other application that it's using it, and maybe has nothing to do with the change you're adding. You just added the field, or just moved the field around, or whatever. But if the other application doesn't have the proper record definition, it crashes, because records are actually tuples. And so if they don't have the same number of elements, boom. And so you have to basically remember where you're using this thing, or grep through your whole set of applications. It's a nightmare. And it's far better to just keep that record in one place, create functions that work with it, and do the pattern matching and everything, and just use those functions from outside. And with that approach, each time you need to change an internal representation, you just change it in that particular module, in that particular application. it's encapsulation 101. Everybody that works with objects knows about that. It's the same thing. You keep your properties private. In this case, it's the same. By 10 years ago, you could not specify that. So even if you tried to hide stuff like that, there was nothing preventing others from violating that rule. And so you were never sure that there was no other people using what you created. And you write your comment and says, don't use it, but that's all you can do. These days, you can specify a type as opaque, specify your functions, and then when you run the Elixir, it will tell you that you are working with stuff that you should not be working with, and so it's your problem, not mine.
Okay, got it. Cool. Yes, go ahead.
Can I go ahead? Yeah, so I had a follow-up question on the opaque data types. On that slide, I wasn't familiar with the syntax where you're passing, I think, T and F or something into the type.
Oh, yeah.
Can you explain how that works?
Parametric types, yes. I come from Haskell, so for me, that was the natural thing to do. But let me show you. So, I did that. This slide is wrong, actually. I should fix it. Let me. You're seeing my screen, right? Let me just fix it really quickly. That's the thing. So basically, parametric types are types with other types as variables. So in this case, this is an example with this, say, integer. Look at this one, the second one. You see integer and integer, right? So this is an instantiation. This can be something like this. There you go. You see?
Okay.
So you can instantiate the other type with the arguments. I will actually leave it like this. I think it's clearer. I will probably have to explain this every time I show this slide, but it's worth it. So you can have parametric types, basically. You can have types with multiple arguments, and you can instantiate it. I tell you one place where that is actually very, very useful. I don't know if that happens in Elixir, though. But in Erlang, you have for matching stuff up in ETS tables. Sometimes you want to use a record with underscore as an atom to ignore some fields, right? And if you have an integer field, you can write a match spec with the underscore, and it's valid. It just means ignore it. But it's not valid in terms of type. It doesn't type check because the atom underscore is not an integer. So the Elixir complains. So in that case, you define two types. One, which is, you define a parametric type, like the T here, and you define a type T with the proper arguments, and a type, say, match spec with the proper types, also underscore. So integer pipe underscore, you see? And so you can use the match spec for match specs and the type T for real stuff. And you can guarantee that they have the same internal structure because both depend on the type T that defines the structure.
Okay, that makes sense.
Yeah, it's an obsessive typing. You can just don't spec those functions, but since I spec everything, any other questions?
Brujo, another question. In terms of types and dialyzer, is there any specific workflow that you feel like it works really well to distribute dialyzer for your users of your libraries?
No, nothing in particular, but I generally add a note to my libraries that this library has specs and it's checked with the Elixir, so I am not writing code to handle the invalid types. That's your responsibility. I wrote the specs. If you run the Elixir on your code using my library, you will be covered. If not, well, it's up to you. You can see what you want to do.
Right.
But it's basically saying the Elixir is a default tool for us. If you don't run it, you're missing it. You have to run it.
Got it.
And I tell you, these days it's much nicer. I hear people, I hear and I read people complaining about the Elixir speeds these days, and I laugh so much because like I tell you, 10 years ago it was, for a system with whatever 20 modules, it was 1 hour, like every single time. There was no speed up. The PLT was forever and stuff like that. It's super extremely optimized these days.
Awesome. Okay. So does anybody else have further questions?
Oh, there is something in the chat.
Oh, let's see.
Are there any good examples of a mixed CI setup for an open source project? Oh, let me check. Yeah, I think I have one. Hold on. Looking. Oh no, this one is in Erlang, so it's the other one. I will get there. You can keep talking about the other stuff. I will get there. Not this one. I'll tell you what. I will find one, maybe because the ones that I'm using are in private repositories, and I will paste what I can on the remote meetup room in Slack.
Perfect. Okay then, Brujo.
Okay. Thank you.
Okay, so before we finish, let me just say this. Brujo, once again, thanks a lot for being the first volunteer of the remote meetup. The talk was really great, and it was really nice to listen to it. And we look forward to having you again. And yeah, so thanks everybody for participating.
Thank you.
Thank you. Bye.
Right.
Thank you.